Equations involving absolute value. Let us first define what is an absolute value of a real number a. The notation is given by this. The absolute value of a is negative a if a is a negative number, and the number a itself if a is greater than or equal to 0. So we have examples here. So in this case, your a is a positive number, then the absolute value of that number, it's a number itself. So for number 2, it's negative 5. So if a is negative, the absolute value is the negative of a, which is positive 5. And when you have this third example here, again, this is the negative number, so the absolute value is the negative of a, which is positive 3 over 4. So you would notice here that their absolute value would always be a positive value. So what if we have equations that involve absolute value? So here let m and n be algebraic expressions and k is a positive constant. So our algebraic expression here has only one variable. Okay. So this equation is equals to k. So either the expression inside this m is equivalent to k, or this m is equivalent to negative k. So let's look further what happened here. So if m is equals to negative k, then the absolute value of this would still be k, which is equals to this. So there's also two more cases here when you have two expressions wherein your absolute value of m is equals to n. So same thing, either this m is equals to n or the value of m is equals to negative n. Similarly, if you're having equations wherein the two sides have absolute value, we are doing the same computation. It's either m is equals to n or m is equals to the negative of the other number. Let me give a simple example. So if I ask you what's the absolute value of x and that value is equals to 3. So x is either equals to 3 or x is equals to negative 3. So let's have more complicated examples here. So if we are saying that the absolute value of 5x minus 3 is equals to 1, so either 5x minus 3 is equals to 1, so that this expression will be equivalent to 1, and we know that the absolute value of 1 is 1, or 5x minus 3 is equals to negative 1. Because if the number inside here is equal to negative 1, the absolute value of negative 1 is still positive 1. So we just have to solve for x. This is just a simple linear equation. So this is equal to 4. X is equals to 4 over 5. For the other linear equation, 5x is equals to, that would become positive 3 minus 2. So that's 2. So x is equals to 2 over 5. So our solution set will have two elements here. We have 2 over 5 and 4 over 5. Okay. So next example. So either 9x plus 2 is equals to 2x plus 1. Okay. So when you get the absolute value of this number, it's equal to this itself. No. So these are just linear equation. Okay. So this is the first of the two solution. So this is 7x is equals to negative 1 and x is equals to negative 1 over 7. So the other equation is that 9x plus 2 will be equal to negative of 2x plus 1. Okay. Because if you take the absolute value of whatever the value of this one, it would become equivalent to 2x plus 1. So 9x plus 2, we distribute the negative sign. That's negative 2x minus 2. Transpose, that's positive 2. So this is 11x. And this becomes negative 2, and we have negative 4. So x is equals to negative 4 over 11. So our solution set is composed of negative 1 over 7 and negative 4 over 11. More examples. Okay, so here we have the absolute value of 5x is equals to absolute value of 4x plus 11. So very similar in solution. You have 5 minus x is equal to 4x plus 11, or 5 minus x is equals to the negative of 4x plus 11. So solve for the linear equation. So transpose this, that's negative 5x, and transpose 5 to the other side, that's negative 5, so this is 6. So x is equals to negative 6 over 5. For the other linear equation, 5 minus x is negative 4x minus 11. Okay, transpose this, that's positive 4, so that's 3x, and then transpose positive 5, that's negative 5, so that's negative 16. So x is negative 16 over 3. So your solution set will have the elements negative 6 over 5 and negative 16 over 3. You can do checking if you have the correct answers by substituting this to the values of x and see if the left side will be equal to the right side. Okay. So here we have an absolute value that has a rational expression. So we are going to apply the same thing. Either you have 6x minus 1 over x plus 5 is equals to 2, or 6x minus 1 over x plus 5 is equivalent to negative 2. So we just have to solve for the rational equation. So we can multiply by the LCD of x plus 5, so 6x minus 1, or simply cross multiply. That's another term for that. Then you'll have 6x minus 1 equals 2x plus 10. Transpose 2 negative, so that's 4x, and then transpose negative 1, that's positive 1, so that's 11. So x is 11 over 4. Then for the other equation here, same thing, we cross multiply, but we're going to have negative 2 times x plus 5. So we have to distribute negative 2. Okay, so 6x minus 1, multiply negative 2 to x, negative 2x. Negative 2 times positive 5 is negative 10. Transpose, so again, we have 6 plus 8, 6 plus 2, that's 8x. And if you have negative 1 transposed to the right side, that's positive 1. So that's negative 9. So your x is negative 9 over 8. So our solution set is negative 9 over 8 and 11 over 4. By the way, since you have an x in the denominator, let's just make sure that there's no value solution of x that will make the denominator 0, just to be sure. And obviously, you can see that if we substitute this both x, the denominator will not be 0. Now, for this one here, this is a special type of absolute value. If you take the absolute value, the answer is negative 3. But remember, in our earlier discussion, we are saying that if we take the absolute value of any number, the answer should always be a positive number. So hence, there can be no x here that will result to an answer of negative 3, because taking the absolute value will always give you a positive number. Hence, yours solution set here is empty. So you may write no solution, or you can just have the empty solution set.